Okay, so for this question, we've got let 1 plus x to the power of n equals c0 plus c1x plus c2x squared plus dot 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 plus ckxk plus cnx to the power of n. So this is just a binomial expansion, the very common one, right? 1 plus x to n. And you want to show that ck over ck minus 1 equals m minus k plus 1 over k for k from 1 to n. And then you want to deduce this. So the ratio in this way is equal to m over 2 m plus 1. So you should be able to recognize what the coefficients are. That's just your binomial expansion. So in other words, ck is just going to equal nck. Ck minus 1 is going to be nck minus 1. And then it's just a bit of algebra work for part 1. So let's do that. So noting, of course, that ck is nck, which is n factorial over n minus k factorial, k factorial. Then ck minus 1 is ck minus 1, which is n factorial over n minus k minus 1 factorial, k minus 1 factorial. So once you expand the brackets, it works out this way. So now you want to take the fraction. So ck over ck minus 1 would just be n factorial over n minus k factorial, k factorial, divided by n factorial over n minus k plus 1 factorial, k minus 1 factorial. In other words, it's n factorial over n minus 1 factorial, k factorial. Now when you divide by a fraction, you multiply by its reciprocal. Now, it's probably quite clear that n factorial just cancels out. Now, it might not be so clear, but let me write it this way. So I have in the denominator k factorial. I'm going to pair it with k minus 1 factorial. And I've got in the numerator n minus k plus 1 factorial and n minus k factorial. So basically, I'm going to think of it like this. That might be easiest. Now, it's a factorial divided by a factorial. Now, consider n minus k against n minus k plus 1. They're both a particular number for a particular n and k. So it's just a number. Now I've got a number factorial, and n minus k plus 1, well, if you think of n minus k as one number, then this is just going to be bigger than the bottom number by plus 1. So, I mean, if you think about like 5 factorial over 4 factorial, that's just 5 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1. Basically, the bigger number cancels out all the other numbers below it from the smaller number. So because there's a difference of 1, n minus k plus 1 is bigger than n minus k, leaving just n minus k plus 1 without the factorial. And this one, well, k minus 1 is smaller than k by 1. So very similarly, k factorial will be left with k, while cancelling out all the other things from k minus 1 factorial. And therefore, n minus k plus 1 over k will be our answer, which is what they're looking for. Now the next part asks us to deduce that c1 over c0 plus 2c2 over c1 plus 3c3 over c2 plus dot dot plus kck over ck minus 1 plus dot 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 plus ncn over cn minus 1 equals n over 2n plus 1. Well, this question, it asks us to deduce that. So that strongly hints that we might want to use part 1. So let's keep that in mind over here. So we've got ck over ck minus 1 equals n minus k plus 1 over k. Given that they've given the word deduce, that strongly indicates we're going to need to use that at some point. Now, you can think of this in terms of sigma notation if you like, if you're comfortable with that. But if you're not comfortable with that, I mean, it's just going to be helpful to generalize, right? So let's think of this term. Let's think of the case term, all right? So this is the case term, is k times ck over ck minus 1, because if we can see the pattern with that particular term, and we can simplify it perhaps, then that means we would know, well, all the terms, right? In simplified form. So k times ck over ck minus 1 is k times, well, ck over ck minus 1, we've got here on the right-hand side. Over here, we've got a simplified version. We know that's n minus k plus 1 over k, which, well, the k just cancels, telling us that this, every single one of them is just n minus k plus 1. Every single term can be substituted by n minus k plus 1 for the right k, obviously, right? So in other words, the left-hand side is actually, thinking about it this way, it's the sum of ck over ck minus 1, where k goes from, well, 1, right? Because when k is 1, you've got 1 to n. But that is just summing from 1 to n of n minus k plus 1. So in other words, I mean, we can do it in sigma notation, but I'll expand it out in just, so that means when k is 1, we've got n minus 1 plus 1. If when k is 2, we've got n minus 2 plus 1. When k is 3, we've got n minus 3 plus 1, plus n minus n plus 1. That's basically what you're adding up, right? Every single term has become n minus k plus 1. And really, you don't need to worry about the n's because, I mean, how many terms are there, right? This is k equals 1, k equals 2, k equals 3, k equals n. There are n terms, which means if you just look at it one by one, the first one's going to be n plus n plus n plus n plus n. You're going to have n plus n plus n plus n plus n times. Then you're going to plus minus 1 plus minus 2 plus minus 3 all the way to minus n. And then you're going to get 1 plus 1 plus 1 plus 1 plus 1 n times. Well, if you've got n n's, that's just n times n, which of course is n squared. Now, this, you can take out a negative, and then it's just 1 plus 2 all the way to n. Now, that's just an arithmetic sequence. And if you use your AP sum of an AP, you'll get that. And then plus 1 n times will just be n. So, interestingly, I don't think I get that. N minus k plus 1, because we want to get n over 2 n plus 1. Now, we've got n squared minus, oh, right, this is a minus, so it's not exactly that. Okay, so maybe we are on the right track. So let's expand then, or maybe let's take a half. So that means you've got 2n squared minus n plus 1 plus n. So that means you've got 2n squared minus n squared minus n plus n. So the minus n plus n cancels, meaning you've got n minus 1. 2n squared minus n squared minus n plus n. Look at n as 2. Let's see. K times ck over ck minus 1 is n minus k plus 1 over k. Let me just do it in sigma notation, see if I get the right answer. Maybe so k equal 1 to n of n minus k plus 1, which means I'm going to be summing from k equals 1 to n of n minus the sum of k equals 1 to n of k plus the sum of k equals 1 to n of 1. N is a constant, so it's n times n minus 1 to n. So, I mean, that's n numbers times n plus 1 over 2 plus n. So that's going to be n squared plus n minus n squared plus n over 2. So it's going to be 2n squared plus 2n minus n squared plus n over 2, which is going to be, well, n squared plus n over 2, which is n plus 1 over 2. And there's your answer. I must have made an algebraic mistake somewhere here. Right, there should be a 2n here. So if that's a 2n, then that means that should be plus 2n, which then means I'm going to get half n squared plus n, which is half n plus 1. And that's how you do it.